Let's now consider how to construct an unambiguous grammar for this language. Thankfully, constructing the grammar is pretty easy. We can sort of think of what the smallest possible even length palindrome is, which is our epsilon. And we can consider the fact that if I have an even length palindrome and I add the same character to the end of it and the start of it, it's still an even length palindrome, which gives us these other two productions. Okay, we've got the grammar. Now we actually have to prove two things. We have to prove that this grammar really does generate the language. And we can show this by proving two statements. We have to prove that if the string is generated by the grammar, then it's in the language. And we have to prove its converse. If the string is in the language, then it's generated by the grammar. So let's have a look at this one first. If generated by grammar, then in language. The way we can prove this is by basically considering all the options for the production rules that we have. It's pretty clear that this is true for epsilon, as epsilon is in the language of the grammar, and we have that epsilon is a even length palindrome, right? Next, what we can consider is we can assume the property to be true for any string derived from s of some length, of some derivation length, and then still prove it's true when we add one more derivation afterwards. So formally, we will assume the property is true for any string alpha such that alpha is derived from s in n many derivation steps, and we'll prove it for any string beta with n plus 1 many derivation steps. Now, if there's n plus 1 many derivation steps in this derivation here, it's pretty clear the first production rule we use cannot be s goes to epsilon, because then I couldn't do anything afterwards and it would be a derivation of length 1, right? So the first step is going to have to be this or this, right? So we have two options. S first goes to 0, gamma 0, or S goes to 1, gamma 1, for some string gamma that can be derived in n steps. Then by inductive hypothesis, it must be the case that gamma is an even length palindrome. And clearly, when you take a even length palindrome and put the same character on the start and the end, then they're also even length palindromes. So these strings are also in the language, which means so is beta. So therefore, we have proven by induction on derivation length that if the string is generated by language of the grammar, then the string is in the language. That is, the string is an even length palindrome.